Hi, I'm Chase McMichael. I am the CEO and co-founder of a company out at Menlo Park called InfiniGraph, and we are a video deep learning company. So what I'll be showing you today is some of the work that we've been doing for the last 3 years, and definitely want to make this interactive. So the presentation is actually video-based because we're a video company. Who here is actually in the video industry or using video encoding? Any video production, maybe broadcaster? Awesome. Yeah, so I actually got started in video about 15 years ago where we were doing video contesting and created a really cool platform and really cut my teeth in digital video of, it was rap battles where, people would upload a video and, get in front, create traffic for advertisers. And that's really was my entry into making video applications. Then I got later into the advertising space. I realized there was a lot more money in advertising. That was before it was a bad word. And and quickly, there's no question about how big video has become. It's really become synonymous, and obviously that's one of the topics we're going to be addressing tonight. And then, can you hit play? Sure. So we are going to hack digital video, and we're going to go into talking about what we're doing specifically around deep learning and some of the visions and direction. But a little background on InfiniGraph. We were a big data insights analytics company about 3 years ago. And we created a very large data set. And I was like, that's literally 3 years ago. So we have about 7 million videos in our system today that we're processing. Yeah, and you'll see there in the center is some of the advertising we were doing for Paramount and Disney. What was cool is that we learned some very important factors, which was taking social content, finding out what was trending, and then being able to put that over AppNexus. That was a ad network. But we quickly found that if we were to change out visuals in the video itself, we would get some tremendous amount of take rate, meaning clicks, or people would be willing to hit play. And you'll see here, this is for Interstellar. This is an actual image rotation, so we're going to go deep dive onto why these images look like this, why they were selected, and specifically what we're actually doing to figure out what images you as a consumer have a cognitive reason to click. So here are some 3 major crossroads, and we're really at an incredible time right now when it comes not only to just computing power, but deep learning, but fast and big data is obviously a big buzzword, but for video, that is a very critical component, because not only are you processing millions of videos, but it's the amount of data that you're having to aggregate, and that's what we call the data pipeline. So if you're here and you have access to a data pipeline, you actually have a leg up on everybody, because the technology is literally becoming almost free. And so, and obviously we'll be talking about some of the technology that's come out recently that's really democratizing, I don't want to say artificial intelligence, because I don't think we're really there yet, but definitely around deep learning or convolutional neural nets. So clearly we're going to talk about what specifically InfiniGraph has got involved around with deep learning and really understanding the reasons why humans interact with content. And so that's one of the things we're going to talk about, and there's some machine intelligence. But, Tensorflow, which we're very excited about, OpenCV, which has been around for a long time, Baidu, who just recently open sourced their AI, they call it AI, Facebook, which is fair, and Torch combination. All of these have become open source platforms. So you're talking about millions, if not hundreds of millions of dollars has been invested in open sourcing technology that frankly would have never been available to any of us. So really for the first time, we're having access to some incredible technology, which is a sentinel moment in this industry today. And then GPUs, and these are like embedded GPUs. This is the tensor processor GPU. This is the open source platform that Facebook came out with. It's optimized for Tesla, the Tesla cards, NVIDIA. And these are some very exciting times, because the gamers really helped us get to these technologies that are speeding up. But they're even saying recently that they want to see these systems go 10 to 100 times faster. And we were very lucky that a guy named Tony had actually created a custom 8 GPU box that we're using today. And this is an 8 GPU Tensorflow box that we're doing some really cool stuff with. So let's talk about the video explosion. I know I went through that really quick. But that's why I'm here, is that's what's happening and why we got into the business. And I just use a show of hands, who has played a video in the last week on a digital device? Everybody. It's ubiquitous. And what's cool about video is it's really the ultimate communication tool, because humans, we are living in video. My eye is made to see video. I'm doing a video of you right now. And that's a human element that's baked into every mammal on the planet. So this is one of the examples right here where, and I'll address this later, but this sequence of images was actually selected by humans, which is pretty incredible because it's a pretty killer sequence of a Game of Thrones video. And we'll be talking more about why and how we figured out why these were the images that people resonated with. And that's the exciting part. But here's some really live examples of Game of Thrones, Star Wars, more Star Wars, a daily news article with David Bowie. And all of these were individually selected images that we pre-process video. We're going to talk specifically about how do we go about pre-processing video at scale. But I'm actually showing you the end product. And all of these videos you're looking at here, and in this one in the middle as well on mobile, got over 100% improvement. That's phenomenal. So what we're doing is we're really tapping into this cognitive firing within the mind, where we're saying which image in the video is actually causing people to act on and take an action. That's a big deal, because for advertisers or people that own video content, that is the holy grail. Get people to stick around and play video. And who here heard about Facebook's manipulation of plays? Anyone hear the news on that? A couple people? Yeah, well, not surprising. So video creates a massive data pipeline. So that's that first component which we talked about, that to create a successful deep learning company, you really need to have an incredible data pipeline. And obviously, like location, streams, and all of this data is literally flowing in at once. And that is a hard problem, especially for publishers. They're just having a hard time getting it out on the web or getting out through their feeds. Now, what do you do with it? So there's a lot of information, and that's why we call it the data pipeline opportunity, because we want to not only analyze what's happening in the video itself, the images and objects, but then what are people doing? What are they acting on? Where are they bailing out? What are they engaging on? So those elements really bifurcate the data layer. So it's no longer just, did someone click on it or view it, but there's a whole plethora of other data that we're very excited about. And this is around the human actions. So remember, I was talking about the fact that humans would touch or engage with the video. Well, for us, that enables us to explicitly tell us which image in the video was most relevant to that audience. So we're able to pour that information back into our system and say, well, let's find other images like that and identify that, and that becomes our training set. So we're using crowdsourcing a very large audience to tell us explicitly what is important to them. And then obviously we've got keywords and all the metadata that goes along with the video, which is very valuable. So bringing together that information, and this is actually the actual film sequence of Interstellar. So we do a pre-processing, which clearly we're going to talk more about, but I just wanted to show you what it looks like. And this is all the images that we deem would have a high probability of engagement. But at the end of the day, we want to say, well, which ones actually achieve the maximum engagement? And that's where that becomes the learning aspect of what we start off with. And then that's the fact that, once we know that someone's taking an action, that means relevance. So that we're, when you're thinking about hundreds or millions of people taking action on visuals, that crowdsourcing has a huge amount of value. So this is where deep learning and prediction begin, is the fact that I'm understanding what visuals in an entire video sequence are most relevant to your audience, and then we're being able to pour that back in actively and be able to learn from that. And that's how we actually create a self-improving algorithm. So here's some, this thing's going faster than it should be, but the human's having to keep up with the machine. So this is an actual OTT environment. So the examples I'm showing you here are just basically that we are being exposed every day to images. And the question is why are those images relevant to us? And in the last literally 20 years, it's been a guess. Well, we literally want to change that with deep learning so that it's not a guess. It has high probable that you will then be engaging on. So this is OTT environment. I'm just, again, showing you very similar examples of images. And all of these images are today, believe it or not, hand-picked. But we're actually embarking on, and our product's called Kraken. And it's ostensibly the first video deep learning technology. And our whole mission as a company is to find the best image in a video sequence. And so here's an actual example of a video that we processed. And I don't know, here's Warriors fans. I'm a Warrior fan. So depending upon which image, let's say if you're a Cleveland Cavalier or you're a Michael Jordan fan, depending upon which visuals show, your brain actually lights up. It's just the fact. So whichever image that you're going to engage with or you have an emotional response, we want to know that. And what's cool about what we're doing is we're actually, the fact that we're breaking apart the video and creating high quality images or sequence of them literally allows us to create a visual story. And you'll see the end product, which is I'm going to show a tile base. And so everyone in the room is going to potentially gravitate towards one sequence or one set of images in this video body. And that's the cool part, is that this is where it really gets interesting. Because now we're saying, well, it's not just one image, but a 3-minute clip has 5,400 frames. That's a lot of information. So thinking about, wow, okay, that's 5,400 frames. Well, which frames are most relevant to you? And that's the art of storytelling, is being able, how do you bring that information together? And then our job is we want to figure out which ones are you not only willing to engage with, but create a probabilistic equation around that and say, if we were to show you another type of image, would you engage with that as well? And that's really where the fun part begins. And this is that cognitive response I was talking about. So yeah, this is actually a breakdown of all the clips. And then what we're doing is we're actually going through and then segmenting out the actual individual images based upon quality. And then we'll look back and pass and say, well, did these perform well? And I feel like that said it again. So as soon as this gets through, we'll go to the next part. I don't have a clicker. Here we go. So this is the breakdown of all the images. And the one on the right was the default thumbnail, but all of these images that you see here are the ones that were deemed as having a high probability of someone engaging with. So it could be 50, 100. So as soon as we have a set of those are the ones that are put out to the audience. And then we quickly do what's called an A/B test. So we'll do a 90-10 split. So 10% of the traffic will go to the default thumbnail, and 90% will go to Kraken. So we'll quickly find, and that's the aspect I was talking about where we're using the audience to help improve our system. So very similar to how Google did with, they sent out road signs for doing the CAPTCHA, where they crowdsource people to identify. We're doing it on the scale of video. And so this is the low-cost approach. So one of the things is it's very expensive if you think about trying to run a convolutional neural net on thousands or millions of frames, and particularly if you're doing that real time, there's just not enough compute power. No, I'm not Facebook, so we can't afford that. So there is a very low-cost equation out there. It's been around forever, and it's called entropy, and this is sort of the definition of entropy. And what we've done is done a modified version of that. So it allows for us to ingest video, run a mathematical equation across the video, so we can basically identify quality. And I'm going to show a series of slides of some real data. And our chief data science here is Paul. And so you can talk to Paul later and ask him some questions about specifics, because he was the mastermind behind a lot of this. But this is the entropy equation, and you can actually Google and look it up. And this is being used for image processing for a long time. Reason why we did a modified version of that, because we had to make it faster. And here's the sequence going from grayscale to the entropy. And this is the entropy scale, which you'll be seeing here in a second. And what's cool about this is it allows us to quickly process massive amounts of video to get down to specific images and then be able to test those images across the audience. And that's part of our learning set. And then one of the things that's not interesting is blur. Sometimes there's good blur and there's bad blur, like if someone's running versus just a bad blur image. That's a very hard problem that we've been able to work out. But being able to segment those out, because at the end of the day, our customers don't want to see bad images or nonsensical images being shown. So we have to be very careful. And then there's simple things like grayed out screens or transitions, so you got to throw those out as well. And then what you end out with is a really good body of images that you can do what's called the real-time A/B test. And this is a cool graph here because it actually shows that our selection is actually working. And that's the cool part, is that we're able to put this back into the system, and that's that self-improving. So the red dots here are actually the ones that had high entropy, and all the blue dots were the selections. And then, as you know, video, when you release video, not every video is viral, right? So when you release a video, it actually has a time to live. So many people will engage with it, and it'll have so much traffic, and that's just how video works. There's too much of it. But you can see here the slopes here is that some video dies fast and some video dies very slow. And that we actually use that information to actually adjust the sequences of images that we would show on a recursive basis. And then here's another example of where we're interested in faces, size of faces. Believe it or not, humans really like faces. It's baked into our reptilian mind. So this is interesting to us as well, as we want to detect, well, is there a face present? And then how large is the face? And believe it or not, if it has a little larger face, people will light up. And this is, when you see the scale of the data that we're looking at, it's very fun because, and now I blurred out a few things that we don't show people, but this is a side-by-side element. So we're showing the blue line is entropy and everything else is something else. So the goal here is to, obviously you can see it now. So here is a collage of what's called a pattern where we're segmenting patterns, and this is very common. And basically, you're wanting to group light-based images. So, and then the cool thing about that is that you're able to then group light-based images, so that becomes a cluster or a view of clusters of what people would resonate with, because you're grouping images that are relevant. And I just wanted to put this out here, Google Vision. We're very excited about this because this is some of that open source. And if you don't know this, Google has an API, so you can pump in images into their system and they will give you classification back, and it's unbelievable. And that's what I was meaning about this is a sentinel moment for this industry, because it's really changing, and just the degree of information that they're able to tell you the type of animals, and now they're coming out with what's called emotions, where they can actually tell you what emotions people have. So this is incredible, and it's an API driven. So we're talking about really democratizing a technology that in the last 5 years was really almost inaccessible. The training set that they have established really gives a leg up for virtually any company. But not only being able to recognize signs, but then they're also doing, and this is the actual code, the output. So it's very robust. So if you've not checked out Google Vision, you really should. But one of the cool things was, and it'll come up here in a second, is it the emotions? Yes. So this is really cool because, just the fact that you can detect who the person is in the image, but then just their facial expression. So they're getting it down to a point where it's really amazing. And this type of data layer we're obviously very excited about. And then this is, identifying specific locations. And for video, this is very important for us because if someone is resonating with a certain type of visual in a video sequence, we want to know, well, where was that? Because that creates a new data layer that then makes a more robust recursive learning set. And this is also like logo detection. So there are obviously a lot of use cases around detecting logos and videos and things like that. But so this is Clarify AI, and the reason why I wanted to show you this is the first time that someone was able to import a video live and then be able to provide you with some base information about what you were looking at. Now, what Facebook has recently done, which I don't know if you've seen, and will be coming out soon, is where they'll actually be reading you the image and telling you, and you can actually interface with the technology and ask what's in the image and what is the image doing. So we're really talking at a next level. And what I'm showing is two different science from Cornell and from MIT. I apologize. There's several, like 8 different universities working on real-time classification. But this is direct examples of being able to bring in streams and process it. Now for us, and this is Facebook, which is another thing which I just wanted to show. And I always like to point out that Facebook is actually picking up the shadow of the bicycle rider, if you can see that. So it's a little interesting that the image classifier is treating your shadow as something real. And so it's not perfect, but this is actually a 3-dimensional or a 3D virtual reality real-time image classification. They didn't disclose what kind of compute power that was used to pull this off, but it definitely shows some of the direction, and we're excited to be potentially embarking in that direction as well. So you see the bicyclist shadow? So it's actually picking that up as being something real. So that could be problematic, specifically around driving and things like that, self-driving. And then okay. So now we're at the point where what's next with video deep learning. So we talked really quickly about image object classification, but here there's the big opportunity is now not only could identify what's in a lot here know about convolutional neural nets. The advancements around that and this free software out there is just phenomenal. And the ability to mathematically describe an image is a big deal. I'm very bullish of Tensorflow because of the community. It's got a whole year ahead of everyone else. So what they've distributed and built out is phenomenal. And there's so much stuff out there that's free. But this is an actual flow diagram of showing the different layering and the ReLU all the way out to the different layers. And I wanted you to listen to this because I was very excited about Deep Viz. So if anybody here is doing convolutional neural nets, I highly recommend you download this.
Recent advances in neural networks have enabled computers to better see and understand the world. They can recognize school buses and zebras and can tell the difference between Maltese terriers and Yorkshire terriers. We now know what it takes to train these neural networks well, but we don't know so much about how they're actually computing their final answers. We developed this interactive deep visualization toolbox to shine light into these black boxes, showing what happens inside of neural nets. In the top left corner, we show the input to the network, which can be a still image or video from a webcam. These black squares in the middle show the activations on a single layer of a network, in this case the popular deep neural network called AlexNet running in Caffe. By interacting with the network, we can see what some of the neurons are doing.
Download this now. It's incredible.
For example, on this first layer, a unit in the center responds strongly to light to dark edges. Its neighbor, one neuron over, responds to edges in the opposite direction, dark to light. Using optimization, we can synthetically produce images that light up each neuron on this layer to see what each neuron is looking for. We can scroll through every layer in the network to see what it does, including convolution, pooling, and normalization layers. We can switch back and forth between showing the actual activations and showing images synthesized to produce high activation.
Isn't that cool?
By the time we get to the 5th convolutional layer, the features being computed represent abstract concepts. For example, this neuron seems to respond to faces. We can further investigate this neuron by showing a few different...
So there's a whole series of this, but I just wanted to share that with you because I'm very geeky and I like that because it is hard to actually figure out what's happening in layers, CNNs, and this is a toolkit you can download right now and run it. But who remembered War Games? Come on, be honest. So that was a very big deal movie for me because this was the first time I was like, wow, machines could learn. And this movie did something really cool because it said, you know, tell the machine to play itself. Well, that concept is sort of kind of foreign if you think about it. And in fact, that's a big deal. And so, you know, they're doing this, saying they're making WOMP play itself and realizing it can't win. And then if you don't know the story about it, it's the nuclear, he was able to get the launch codes and he's going to launch all the nuclear weapons, but he realizes he can't launch the nuclear weapons because there's no win. So he was able to learn, and probably Matthew Broderick here is learning. So 33 years later, so I am
demonstration of general purpose AI.
AlphaGo.
Its name is AlphaGo, and it was made by Google's DeepMind division.
This is a big deal,
The
guys.
AlphaGo AI algorithm beat a human at the world's hardest game.
So
This is a historic moment in computer science and artificial intelligence.
I think maybe the game ended.
No, I don't think so because it looks like he is still counting.
No, I think he resigned.
Wow, I think you're right. Wow. Wow.
This was the moment a computer called AlphaGo beat a master of the ancient Chinese game Go.
So firstly, a few questions. Why is this important, and what's all the fuss? AlphaGo shows that machines can really learn. How so? Well, instead of using brute force to calculate all the moves it could make, like previous AIs, AlphaGo used reinforcement learning and neural networks to mimic the learning process of a human brain. Keep in mind that the ancient Chinese game Go has as many more possible moves than chess as there are atoms in the entire universe. So there's no way of just calculating every possible move on the board. That's practically impossible. For this reason, Go is the holy grail of AI, and learning to do such a task from scratch.
If you ask a great Go player why they played a particular move, sometimes they'll just tell you it felt right. So the one way you can think of it is that Go is a much more intuitive game, whereas chess is a much more logic-based game. So the way we start off training AlphaGo is by showing it 100,000 games that strong amateurs have played that we've downloaded from the internet. And we first initially get AlphaGo to mimic the human player. But of course, ultimately, we would like AlphaGo to be stronger than human amateurs and compete with the top professionals. So the way we do that is, after we take that first version that's learnt to mimic human play, we then allow it to play itself 30 million times on our servers, and using reinforcement learning, the system learns to improve itself incrementally through it avoiding its errors and increasing and improving its win rate against older versions of itself. And after all these games, then you end up with a new version that can beat the old version, the original version, around 80–90% of the time.
So what does that mean to us? So obviously that's very exciting that this is happening in our lifetime. But for us, we're looking at the scale of how many videos are out there right at this moment that are being interacted and shared with. So this is our AlphaGo problem of being able to analyze, process at scale millions of videos. And this is a real example of what's called a distributed array. So when different videos being placed in different places perform differently with different visuals. So we were actually tapping into a regional effect. And that information is not only poured back into our system, so we're able to effectively create a reinforced deep learning solution where we're now utilizing that information to improve our algorithms. And so where we're going to go with this is the sky, and we're very excited about it. But that's what I described about the top images being recycled back in. We do think we're hitting an opportunity where we're actually doing a crowdsourced human intelligence, and we're using that to our advantage. And that's very exciting. And that's my talk. So I'm definitely here to ask questions. And if it's more mathematically oriented, I recommend you talk to Paul. But please ask some questions. Yes?
My question is real simple. As you've intimated in your talk, depending on exactly where in the visual field the thing is being played back, will wind up getting a different score. And I was wondering exactly if you were able to quantify that. How much better is it to go, in terms of placement on the screen, how much better is it to go and have, let's say, a center position and edge?
So I would love the opportunity to do that. And you're thinking very advanced. Believe it or not, our customers are not, they don't think that advanced. It's hard enough just getting our technology integrated into their player and on the page, more or less being able to adjust. I mean, definitely we're embarking, or around us, there's a lot of companies that are doing personalization. I'm sure you've heard about that, which is very popular right now, using data-driven to drive. So we definitely have been asked from certain select customers about saying, hey, can I use this learning? Those are soft, though. When we say, hey, we're going to improve your video performance by 30% average is what we tell everybody. We've done some even higher than that, 40%. So if you imagine you're doing a big network does like 440 million videos a year, plays a year, a 30% bump on that with a $25 cost per thousand is roughly adds about 47 million to their bottom line. So we're talking about very hard numbers, but when you're trying to help someone from a soft perspective, it's more about, okay, you help me with engagement. And that's, which I was in that business for many years, it's the sustainability issue. So really great question, thank you. Yeah.
So I didn't really understand how you picked the initial images to do the A/B with, because as you said, there's 5,400 images in a 3-minute clip. So I understand once you've got a set of images, you run A/B against, you get learning and so forth. But where do you get those initial images?
So that's our magic sauce. No, so the images come from the video itself. But then what we have to do is process that video, and the fact that we have so many other images that we know did well or performed because they had certain characteristics, we're able to use that learning and propagate it forwards to be smart about selecting. And a human does this naturally. You know, matter of fact, you're doing it almost in a passive way. You don't know it. Who here has gone to a museum and saw artwork, right? Well, certain artwork induces certain emotions, and certain artwork you look at and you're like, that's gross, and walk on, I don't like it. Well, that's very similar to what we're doing. We're trying to tease out what attributions inside a video would cause a human to have some type of emotional response.
And the learning of that is based on the earlier A/B tests that you
Yes. And that's the reinforcement element that we talked about, I briefly touched on, because we want to, basically our mission as a company is we want to self-improve. I don't want to be stuck at, 20% or 30%. We want to continuously move upwards, and we have shown that statistically that as we run on more videos on the same site, we do improve over time.
And so one other question. You mentioned the role of entropy. What are you calculating entropy against? Is this entropy in the sense of the entropy that you calculate to determine the number of bits you need to do an optimal compression? Or is it some other entropy?
Entropy is an image density. And Paul has a lot more information on that.
Where's Paul?
Paul's right there.
Want to get with me after?
Yeah, you can ask him that. He knows that a lot more than I do. I'm dangerous. Yes, please. I'm sorry. Next, go ahead.
Question: you mentioned about a lot of different infrastructure like Google and using Teslas, which is the part of the standard. So can you tell us about your infrastructure size? So
Yes.
we're able, to improve this kind of.
So yes. So we're Tensorflow. We like that a lot. That's not the end all. There's some stuff that we're going to be publishing about. It's not one size fits all. But for right now, it's TensorFlow, and we're using that box I showed you that had the 8 GPUs in it.
Only one box for the whole API calls? You probably have a data center. That looks like a box that NVIDIA does as well. They have
well, no, well, NVIDIA has that has 8. NVIDIA has one where, you know, it's a deep learning, and it's I forgot the stats on it, which we would love to have. They're giving them away, but we didn't get one. Right. To be specific, you know, what we're doing is at the very last moment of what should we be processing, because I described before, we can't afford, we're not Facebook. So we don't have this huge server farm where we can process the types of content. So we have to be very specific. So when we get down to top images, we're not doing the whole video. We're just going to say, well, what's interesting in those top images? So that greatly reduces our workload, and we're not having to process, because like a publisher may only be putting out, let's say, 100 videos a week. A mid-sized publisher may be doing 20 or 10. So it's not the volume, it's the quality of information. All of those calculations help us tremendously, because we're wanting to, again, pre-process. At some point we do want to get to a point, and I have lots of discussions with Paul and the rest of the team on how far do we want to go, because there's a cost component to that. And then there's the attribution level, like how much additional attributions are going to improve. And if we're only going to see a 5% improvement, that's not a big deal. So we're saying, can we do a quantum leap? And we're still in the phase of working that and making it better. I'm sorry, the gentleman behind you, I apologize.
You give us an example, it's AlphaGo. Basically, what I know, the AlphaGo used more than 1,000 servers to process it. It seems that's much similar to process this video. Video has so many frames, so many pixels. How large is the computing power you need to process the video to get accurate?
Right, so that was very similar to the gentleman's question here in the front. And we don't want to process the whole video, because that's not helpful. What we want to do is process the images that the humans have told us is most relevant. So that greatly reduces the workload to a very manageable level. And at that point, we're just adding we're basically augmenting metadata. Yes? Am I missing anyone over here? Because I feel like I'm ignoring this group. Yeah, you too, please.
Are you sampling only the 3-minute clipping like trailers, or do you also do hour-long movies?
So like for Vice, it's full lengths. So but for trailers and for movie clips, we have to be careful, because if we ingest the whole film, we may be actually putting out a spoiler. So like shows, and all TV type shows have trailer content and recursive trailer content. And if you something very cool is if you've ever done on an OTT or like a set-top box or YouTube, you run your mouse on the play button across, you'll notice there's an image that pops up. Well, those are actually preview images. So those are available as well. But we have to be careful when we do a full length, because graphic content's an issue. So that's where detection would be very helpful. But also the spoiler issue has been brought to our attention. So there's different use cases. I hope that answered your question.
Yes. Do you also use audio?
No, we don't. We have not embarked in audio. I just had lunch with Paul about audio. Pick your battles. If we can get 30, 40% improvement, that's good enough. We're an 80-20 rule shop. I'd rather just focus on just doing the images, but audio is a very interesting element as well. Yeah.
So those preview images that you have, can you directly jump to that location if I give you a preview image?
So that's a very interesting use case, and that's something that we haven't embarked on with our customers yet, but it's a very intelligent use case, and thank you for bringing that up. I think the challenge is, for certain humans that would find certain sequences or segments that you could jump them to, could be more relevant, and definitely that is something that we've definitely talked about. So very smart of you to pick that out. How that scales out in effectiveness, we haven't actually even put anything like that in motion. Yes?
How do you adapt to a changing audience? I'm thinking, for instance, if you train on mostly men
They're always going to go for the girls.
Exactly, and then you start showing it to women, because of things.
Right. You know, this is a very important conversation we've had with multiple customers. And one of the things that we've noticed is that the placement of the content. So a video may get placed, and we have several use cases like this, where a video will be placed on different publisher sites. One will be skewed more female, one will be skewed more male. And in that case, different images do show up. So we're naturally doing that. Then there's the location element, where there's different people in different locations will resonate to different, they'll have a higher efficacy to different visuals in the sequence. So great question. We don't want to take on the burden of doing PII. If everyone know what that means, private information. And so we want to be able to do it at a higher level, and that allows us to scale. Yeah.
So it's still not clear to me what your success metrics are. You're looking for your viewer, you want them to keep watching the video, you want them to have a positive emotion.
I'm going to add that in my presentation. Thank you so much for saying that. I was on the edge of adding that. I felt it was a little too much geeky. So we do it's called a split curve. So we're running in parallel all the time on every single video a 10% allocation to the default thumbnail or editorial pick. And then 90% goes to Kraken. So at any given moment, we can show a split curve of when the content launches and then the split out, and then that delta is the lift. Now there's also a thing called completion rate. There's a whole host of other variables that bifurcate that drastically. So for what we're getting benefited on, especially for the customers, is they want to increase take rate. So that's one of the number one things. And then there's a completion rate, and that's more, unfortunately, we definitely improve that, but that's very content dependent, because now you're in the content. Now, one of the things that we do is we'll show, as you saw, the sequence. So humans are not a single visual species. So the web is sort of kind of, in our mindset, is broken. And so when you go to a web property or any type of content, you see one image, and that's not enough information to get me sucked in to commit to a piece of content. So that's why we actually show 4 different images. So that sequence you saw, the Game of Thrones, where the girl has her hand up and it goes down like this and down like this, we didn't do that. That freaked me out. I was like, oh my God. The audience selected those in that order. So that means that every one of those motions, and then, created a visual response. Well, that created a story. That was a visual story. So that actually performed almost like 150% improvement. So being able to display sequences of image allow the human brain to get a better picture of what that story's about. Any more questions? Yes.
So you mentioned that humans tell you which images are relevant to them. How do you collect those signals from the video? Because somebody plays a video, they generally play it all the way to the end or stop it at some point of time. So what are the signals you're able to collect to understand what images are relevant to the...
Yeah, so imagine if I had, this is the ultimate in a focus study. Instead of having a two-way mirror, I'm displaying out to tens of thousands. We've had videos that have millions of engagements. So the ability to distribute a series or a set or a cluster, a set of images, and be able to test those in real time allows us to do something pretty phenomenal, which is we're tapping into human intelligence. They're implicitly telling us this image is most relevant to me. And we're doing it on a crowd basis, so it's not individual, but we're grouping, so let's say 10,000 people, every 1,000 are getting a set of images, and then by being able to delineate those down, that becomes our set that we'll pour back into our training set. So that's how we're self-improving. That's the cool part about Kraken.
So where do you get that information from? Sorry, might be just
crowdsourcing?
Oh, yeah. So since our technology lives inside the actual video player that sits on the broadcaster or publisher's page, then we're just like a Google Analytics inside their player. So we know everything that's happening all the time, everywhere. And we have all that metadata and all the log type file data coming back at us, along with the fact that we have a stream of images. So we're grouping up, that's our big data problem. It's quite a bit of data. There's more data than we know what to do with, actually. So, but that should answer your question. Yeah?
How often do you have to redesign your deep learning now?
That's a great question to talk to Paul about. We're greedy. We want to make our selection. If I had it my way, I don't want to. I want the system to say, "Hey, here are the images." So we're not wasting a half a second, because some of these videos get huge traffic right when they're launched. I mean, we're monstrous amount of traffic. So I don't want to waste any time, because every second, I'm not going milliseconds of time, we're wasting on saying, well, is this a good image? I'd rather have our system, and that's really our ultimate destination, where we predict. We're already saying we're so smart. Our systems are so smart. We just look at a video and we can tell you what it is, and that would basically reduce our testing time frame to 0. And that means that our profits would obviously go up, because we're not leaving money on the table. Usually we process things within a minute, but sometimes it takes several hours because of the traffic sporadicness. So it varies. Answer your question? No? Well, then ask Paul. Yes?
So as a filmmaker, you identify faces are a good thing.
Well, not always.
Well,
depends upon the scenario.
Okay.
But that information could be used to
Are
improve.
there other things that have come out that are most often favorable? If I'm a filmmaker, what else should I do?
Yeah. So we've gotten that question from people on how do I use this information to make better content, there is 2 companies out there that are actually crowdsource content, like from Getty Images. They do read the content on the page as a keyword, and then be able to create video on the fly. So in some point in time, we will be able to potentially have an artificial intelligence movie created where it crafts the content based upon learnings of human action. So it's moving that direction. I don't think we'll beat out Stanley Kubrick or anything like that. But as for these short clips and things, this is really important. So being able to basically edit and craft a connected story from human engagement is definitely a path that potentially we could take. Yeah.
So are you looking at the FPGA technology, like the ones that Microsoft showed now? More real time?
No. There's a tsunami of stuff coming out. We can barely keep up with what's happening. I mean, there's so many teams. The stuff that's coming out of the universities is insane. It's a big AI renaissance and push that's happening right now. So, Azure is obviously a cool product. There's no doubt. It's just bandwidth for us. I mean, we're a small team, so we're just staying laser focused on just getting our stuff to work. But yeah, good question. But no, we haven't looked at Azure.
So what does real time mean in your case? Is it like a minute?
Well, real time is relative. Is it nanoseconds? Am I being able to manipulate visuals to a body of individuals that are coming in, which is real time, and that is real time for us. And then at that point, if we're achieving the objective of the customer and they're happy, that's a win. We definitely want to improve the algorithm to be more elastic, but there's a lot of stuff that we're still learning. I mean, we're learning about this every day. Give you case in point, we never saw Game of Thrones content ever. And if you ever see Game of Thrones, it's very dark. It's leather and brown, and so we didn't really have a good sample set of what works. So that was sort of had to be built, where we have tons on sports and stuff. So depending upon the type of content, will affect our speed of which. But once we have like a couple hundred videos and we ran it a few times, it becomes a non-issue. So we're killing it. Yes.
So do the publishers depend on you for the recommendation of other videos, or it is then the YouTube's algorithms which kick in too?
So it's Paul's laughing behind you. That is on our roadmap, yes. And we're very excited about that. That's we're torn between either calling it Kraken 2.0 or Medusa. So which one do you like, Medusa or Kraken 2.0? All right, okay, it's done. So we call Medusa. So Medusa is that was the next evolution, since we're grouping literally essentially millions of images, and they're categorized and structured. We definitely believe that we will have a superior recommendation, and that's the request by customers. So we launched Kraken, and then we want to be able to do that next. Because right now, a lot of the curated lists or playlists that you see are sort of self-fulfilling. And you've probably seen them on sites. They'll say recommended video, and then you'll be head scratching like, why is that recommended? Or it'll be a video based upon traffic, which is the problem with that is if somebody was to put the high traffic videos in front of everybody, well, obviously those are going to get the most engagement, so it's self-fulfilling. And we think there's a much better strategy where it's about visual engagement. So we'll see, hopefully in the next few months, we'll have something live like that. Yes?
In terms of you're using A/B, have you looked at multi-arm bandit? Is that like a business thing to show, like, making sure you have the 90% what they prefer versus the 10%?
So what we'll do is we'll cleverly slip in the default thumbnail into a Kraken set, and that way, if for some reason that image just got more engagement, then that becomes a net out. We don't win on every video. That's just our goal is that we want to win on the majority of videos. At the end of the day, we're there to lift their entire revenue basis on the bulk of the videos. So, but in that case, it's we found that the split test allowed for us to report accurately enough for the customer to feel confident that this was a proper read on the performance of that video and the lift that we could perform. Yeah.
Can you talk a little bit about your efforts around unsupervised learning?
Yeah. So unsupervised learning is a great question. Basically, for us, is the fact that we're identifying good images, but being able to use those as a selective element. And so that, there's a lot of work that we have not done. So we're really at the cusp of actually creating a much more robust. I feel like we're at the infancy level in creating a true, thinking system that is truly doing self-selection. And I would say we're probably around 9 or 10 more months away from doing what you're saying exactly. We're excited about the performance we're getting now, and that's what we're really focused on. And obviously we've talked about some of the specifics around how we would go about doing that and making it better. We only see it going up, so that's the good news. All right, well, thank you. Oh, no, one more question, sir. Yeah. We need more power. We do not, that box I showed you was only a 2 teraflop, but that does a lot. Since we're not processing millions and millions of physical images and doing clusterization, we don't need a massive amount of computing power. So actually, I don't want to have that because it costs. Our goal is to get down to the cheapest and easiest and simplest as possible, because at the end of the day, if we can lower our cost basis for everything, then we obviously create a higher profit margin. Well, thank you.
Thank you so much.